Today we are going to plan and fly the approach and landing to runway 16 at Painfield Airport, situated at Everett in Washington State. We are in the Mooney Bravo at 4,000 feet, approaching the airport from the southeast. We need to do a procedural turn to line up with the runway 16, which means we need to approach the airport from a northerly direction. We have been cleared to descend to 2,000 feet and expect vectors from ATC to guide us through traffic and line us up for the approach in dense fog. First, we are going to do an old-fashioned VOR DME approach, and then we are going to repeat the process using the ILS system. Instrument flying requires both maneuvers, which means physically flying the aircraft, and procedures, which means headings, altitude, and radios. Radios are used for both communication and navigation. We're going to keep the GPS open to keep a bird's eye view on things, but we are not actually going to use it. Some of the older pilots around learned to fly with no GPS, and to be good instrument pilots, we need to be able to do the same. This is the NACO VOR approach chart that we are going to use. The top section contains the briefing info that we need, which consists of key frequencies and other important info for this approach. The upper left-hand corner shows the frequency for the nav approach we are going to use. The next box to the right of that shows the final course over the ground, which may be different to our actual heading depending on wind. The next box to the right of that shows the type of lighting and runway elevation. The plan view shows the final approach and course across the ground from above. The procedure begins at the IAF, the initial approach fix. There may be a few of these IAFs, but there is only one final approach course that you fly in search of the runway. The plan view also shows the path for the missed approach and hold, which in this case is a right turn circuit from the PAE fix. This drawing in the top right of the plan view shows sector heights if we are further than 25 nautical miles from the VOR. The profile view shows the headings and altitudes that need to be flown. It also has the details of the missed approach, which traditionally is a dotted line. In this case, fly the runway heading to 1,700 feet, then turn right to hold on the VOR at 2,000 feet. The minima section, this tells us the lowest height we should be at which point we must see the runway. The MDA equals the minimum descent altitude. MDA here is 1,020 feet MSL. The 24 next to it means that the pilot should have a minimum forward visibility of 2,400 feet. Next to that is the same information in meters. Minima differ for different aircraft categories. The Mooney Bravo is a Cat A, although because it is relatively fast, it's not a bad idea to select Cat B at some airports, although very often Cat A and Cat B have the same values. The section at the bottom right is the airport sketch, which contains various pieces of information about the airport which we may need. This must not be confused with the airport diagram, which is a separate, much more detailed chart. This tutorial is not really about air traffic control, so I've switched off the annoying voices. They always seem to speak when you're trying to do something else and demand that you acknowledge them. It's really nice to have another pilot in the right seat who can keep them happy while you do the flying. You can't see anything out the window at the moment in these conditions, so you may as well set up your screen as I've done. Here we have an air traffic controller giving me a vector to fly and allowing me to descend to 2,000 feet. At the same time, I want to slow the Mooney down from high cruise speed of 160 knots to low cruise speed of 120 knots. Air traffic has told me to expect vectors to land on runway 16R as per my flight plan. You can see that COM1 is tuned to air traffic and COM2 is on the ATIS frequency. Both of my nav radios are tuned to the PAE VOR. My HSI needle is set to 159, which is the runway heading that I will fly to land. I've set the autopilot to descend to 2,000 feet. I have set the RPM to 2200 and I'm gradually decreasing the manifold pressure down to 25. I'm also using my speed brakes to slow the aircraft down. Speed brakes are two little panels that come out of the top of the wing, as in this picture. Now you can see that air traffic is handing me over to the would-be approach. I acknowledge, retune my COM1 radio to would-be approach. I request clearance to do an instrument landing on runway 16 right. They clear me and I acknowledge. They tell me to increase altitude to 4,000 feet. They first tell me to turn right on a heading of 105 and then probably realize it's too soon to give me this heading and tell me to continue away from the airport on a heading of 335. It is important to have good situational awareness at all times. I'm expecting vectors that will consist of a downwind leg, a base and an intercept. If air traffic gives me a crazy heading that might fly me into a mountain, I will know. Air traffic have been known to make mistakes. Okay, air traffic has flown me at 4,000 feet, approximately 20 nautical miles from the airport, and they have finally given me my base vector of 040. I'm expecting the final intercept vector to be given so that I can intercept the 340 radial and fly inbound to the VOR on a 160 heading, which is a reciprocal of the 340 radial. Now they have given me my final intercept vector of 070, which as you can see is different to the published intercept of 115. Air traffic often do that for one of many reasons. I have turned the airplane to the intercept heading of 070 and I'm now going to intercept the 160 heading to the Payne VOR. I will do this by watching the yellow HSI needle, and when it begins to center I will turn onto my final approach heading of 160. You can see the green ILS lines on the GPS, and when I draw level with those I expect the HSI needle to center and I will make my turn. You can see that I have again slowed the airplane to the low cruise speed of 120 knots, and as I draw level with the green lines on the GPS my HSI needle begins to center. Air traffic have now cleared me to intercept the localizer and told me to descend to 3,000 feet. They have also told me to change frequencies and contact the Payne Tower. My needle is now centered and I have told the autopilot to track the heading by pushing the nav button on the autopilot. I'm using the VOR only to find the runway, so I don't have the luxury of vertical navigation. Situational awareness is again important, and a pilot should know the approximate altitude to be at the various distances from the runway. We know the glide scope angle is 3 degrees, so using simple trigonometry we can convert nautical miles to feet and calculate and be aware of the approximate heights which we should be below. You should always intercept the glide scope from below. You can see that my altitude is 3,000 feet, speed 120 knots, but there's still 13 nautical miles to the VOR. I know from the airport diagram that the VOR is significantly to the left of the runway, and in these weather conditions I have to see the runway at 1,020 feet. Otherwise I will have to fly a missed approach. 1,020 feet is only 400 feet above ground level. Here we are with just over 2 nautical miles to go to the runway. Nerve-wracking times, and you have to have respect for pilots of yesteryear. This is all they had to find the runway. You can see I'm at 1,100 feet. I have to find the runway now or it's go around. There it is, way to the right of me. I'm going to have to get over there, line up with the runway and land. We all know that is much harder to do in FSX than in real life. I hope at some stage some smart developer can change the code to mimic real life. I'm going to give it one go and let's see what happens. Okay, well, not on the center line, but on the ground and alive. I'm going to repeat the approach and landing, but this time I'm going to use the ILS system to hopefully bring me out of the fog, lined up with the runway and at the right altitude and speed. This time I'm going to repeat the approach and landing using this ILS approach chart. Nav 1 is tuned into the PAE ILS. At this stage the autopilot is tracking the ILS both laterally and vertically. You can see that the HSI needle is centered. The two little yellow triangles are showing that I'm at the correct altitude tracking the glide scope. My speed is a little high, but I haven't yet dropped the gear or extended flaps. Now with 1.4 nautical miles to go, my speed and altitude is right, gear is down, flaps extended. All I need now is to see the runway dead ahead of me. And there it is. It's a very satisfying in real life and in FSX to pop out of the fog and find the runway dead ahead. I set the weather to be even worse than in the previous landing. This runway is 3,400 feet and we can't see the end of it, so we must be close to the 2,400 feet forward visibility minimum. So let's put this Mooney on the ground and end this video. Hope you enjoyed it, and until next time, goodbye.